All right, good evening, guys. I am recording this at 8:58 in the evening. Just laid the children down to bed, and I was like, I cannot go to sleep without doing a little math, which I know y'all all can relate to that. So I've got my coffee right here, and we are set to go. So what I'm going to show y'all this evening is how to do the dividing radicals. I hope everything went well with the adding, subtracting, and multiplying. If you've not watched that video yet, you might want to look over it first. And if you have any trouble with it, just shoot me an email, and I'll do a pic. I'll work a problem out, take a picture of it, and send it back to you. Not a problem. With its dividing radicals, overall it's pretty easy, but there is a little bit of a trickiness to it that you just got to pay attention to, because at some points it's going to pull back on the skill sets of like the full method and distributive method. So you'll have to remember some of those properties. But here goes. So off this, I'll show you what I'm working with right here. I am on this packet here. So I'm going to tell you the numbers that I'm going to be working out on this packet, and you can just copy them down, look them over, whatever. So so the first I'm going to work out is number. I'm just going to start with number 1. Good place to start, right? Over 2 radical 5. Okay, so with these, what I like to do, think of it as kind of like 2 fractions being put together here. You have 12 halves. So anything that's outside of those square roots, you can think of those as a fraction itself. So 12 halves is really 6/1. And right here, when you have the square root of 160, you have the square root of 5. If they're the same kind of radical, you can think of that as saying 160/5. So you can reduce that. So 5 goes into itself once. 5 will go into 160. Oh, excuse me. Oh, Lord. 6 divided by 5. 3, so that's 15, 1, 10, 32. Okay, so 32. So when I rewrite this, I have 6 times the square root of 32, all over 1, because those went down to 1. So at this point, before I circle it and move on, I got to look at my radical, just like I did with the other ones, and see if I could break this square root of 32 down. And in this case, I can, because my perfect squares, 16. Square root of 16 times the square root of 2 will we'll make 32. So that's going to be 4 times 6 times square root of 2. 6 times 4 is 24. Radical 2, and it is a done deal. Okay, so next one here, where's that? Number 4. So number 4, a little bit bigger. All right, so following the same process I did before. So I look at these numbers here on the outside. I can reduce these. 28/4 is really 7/1. This cube root of negative 16m squared over cube root of 2m. Since this is a little bit bigger, I'm going to do this a little. This one I'm going to do slightly different. You can think of all this kind of like that. They're all under the same radical. Negative 16 over 2 is negative 8/1. M squared and m, that m cancels, leaving that m to the first. It was, I made a mistake. My bad. This is m to the 6th, not m to the 2nd. My bad. So when you cancel this, that is m to the 5th. So my mistake. So this right here, so this went down to 1. All that's left under the radical. So you got 7. You got your cube root of -8. m to the 5th. All of this went down to 1, so really it's just over 1. So 7 cube root of -8 m to the 5th. So now I've got to look at this. Can I break it down? I know that the cube root of -8 cube root of m to the 5th. I'm going to bring that 7 right there. Cube root of -8 is -2 times that 7. I have m to the 5/3, which is like saying m to the 1, m to the 2/3, so 3, 2/3. So that's going to be a -14 m cube root of m squared. Make sure it didn't go. I'm gonna go through and make sure it didn't miss. Okay, yep. So as you can see real quick, these do. Now I am going through a lot. Some of this stuff, like this right here, I figure by now you probably get to where you can do this in your head. Even this right here, some of them you look at and just probably can figure it. But you can see how that there's a lot of process to these. So you'll want, when you're doing these, you'll want to really take your time, line for line, go step for step. Make sure you can justify each step and that it makes sense. That's going to be a big thing for you. So next one, number 9. Let me scroll. Okay, so number 9. Now we're getting into the funner ones. So when we're working these out, we have to do a process called rationalizing the denominator. And we actually did this back in our what unit was it? I believe it was our quadratics unit, when I was teaching y'all how to do like the complex numbers and all, and we rationalized the denominator. But we had like that I that was in the mix with. This time we don't have the I or nothing. But with this right here, what we do, if you have just a monomial in the denominator, which is what this is one term, I'm going to multiply both top and bottom by the square root. That 2, it's fine, don't move it. I'm just going to multiply top and bottom by that square root of 5. Essentially what you're doing is you're multiplying this by 1. So in case you forget the idea of what rationalizing a denominator is, it is we don't like radicals in the denominator of a fraction. And the easy way to get rid of that is just we rewrite it in a equivalent fashion. It just looks different. So when I'm multiplying by square root of 5 over square root of 5, I'm actually multiplying by 1. So I'm not really changing the value of the expression. I'm just changing what it looks like. So multiply straight across. So you're saying 3 times the square root of 5. All right, now down here, pay real close attention to this, because you got 2 times the square root of 5 times the square root of 5. Now I'm really doing this step by step, but a lot of this you'll be able to do in your head within like a couple of problems. But you're saying 2 times the square root of 5 times the square root of 5. Square root of 5 and square root of 5 is square root of 25 times 2 over 3 square root of 5, which in turn gives you 3 radical 5 over 2 times 5. which in turn gives you 3 radical 5 over 10. Last thing you check before you circle it and call it a day, you check these numbers right here because they're not under a radical sign at all, and you just see if you can reduce those. And obviously 3/10 is not reducing, so you're good there. One thing you want to be very careful about, actually there's 2 things you want to watch about. One, when you're at this point, that 10 right here should not be under a square root sign at all, or a radical sign at all. If you put a radical sign, that you're not paying attention to what you're doing. So watch what you're doing. Second thing you want to check for, can this right here be broken down? Square root of 5 obviously can't. Third thing I caution you about, do not, I'm going to put a frowny face and tears. Do not say 5 over 10, like reduce it. The 10 is not under a radical, so don't try to simplify that. So that's a done deal. That's it. So recap, when you're rationalizing denominators. Sounds like a Arnold Schwarzenegger movie. If it's a monomial, just the radical. Multiply top and bottom by that whatever's under that radical. Okay, number 14. Okay, now this is where it's going to get a little bit fun. I guess fun is a relative term with these. Okay, so there's going to be a lot of math to this, so just hang in there with me. And again, you have the power to stop and replay and put in slow motion on YouTube, so use that to your advantage if you have to. So here it goes. What you're going to do is take the square root of 12, multiply both top and bottom by square root of 12. This right here is going to be saying, and I hope I'm not going to run a room here, square root of 12 times 3 radical 2 plus radical 6 all over the square root of 144. Okay, now square root of 144 is 12, so the radical's gone. Yay us. Here's where you got to be careful. You're going to distribute to each thing. So I'm going to say square root of 12 times square root of 2, which is square root of 24. So I got 3 radical 24. Square root of 12 and square root of 6 is square root of 72. Okay, now you're not finished at this point because you have 2 radicals you got to think about breaking down. So I'm going to come up here. Let's do square root of 24. 4 and 6, that's 2 radical 6. So this is really 2 radical 6, but don't forget that 3 out front has to be multiplied by this 2. So you got, let me come down here. You got 3 times 2 times radical 6. Then you have the square root of 72. So I'm going to do square root of 72 up here. So 72. Square root of 9 times square root of 8, which is 3 radical 8. Wait a minute. Having a moment here. Well, that'll work, but I just thought of something way easier. How about square root of 36 times the square root of 2? That's probably a lot faster. That'd be 6 radical 2. Okay, so I'm going to come down here and say plus 6 radical 2. All of that over 12. Now this 3 times 2 is 6, so I got 6 radical 6 plus 6 radical 2 over 12. Alright, so pay real close attention. So technically, this is done, sort of, except for this one thing. Remember, if we're simplifying them, we got to take them as far as we can. So what I notice about this is both of these have a 6 out here in front. If it helps, think of this. I'm going to come over here real quick. If I had it written like this, 6x plus 6y over 12. If I had it written like this, especially as far along Algebra 2 as we are, we should be able to look at this and see, okay, if I factor out 6 and leave it x plus y and set it over 12, the 6 and the 12 can go down to 1/2. Okay, you're factoring out. In other words, you're factoring out a GCF is what you're doing. I'm going to do the same thing right here. So I'm going to come up here to the left, run out of room here. I'm going to factor out a 6. So you have square root of 6 plus square root of 2 all over 12. That 6 and that 12 break down, leaving you square root of 6 plus square root of 2 over 2. That's the final answer. So let's just look over that real quick. Multiply top and bottom by the square root of 12, distributed. Got to right here, had to simplify my radicals, which basically got me to here. So when I got here, this and this had, okay, so and what clued me in right here, what made me go, why would I even consider a GCF? What clued me in was this: 6, 12, and 6. They are all multiples of each other. Or I'm sorry, factors of each other. And I was like, oh, okay, I can. Now sometimes it doesn't work out like that. Sometimes it's like for instance, if that had been like, say, a 5, well, 5 and 6 and 12, okay, there's nothing I can pull out. So does this happen every time? No, it doesn't, but it can. And you have to, especially as far along as we are now, you have to start looking for that kind of stuff. Because remember, you want it broken down until it is as low as it can go. Okay, so, whew. Last one, number 18. Okay, number 18 is probably the biggest doozy of them all. This one I would recommend rewinding this, replaying it a few times to really get your head wrapped around it. Also, by the by, I'll just throw this out at you. A website called CUDAsoftware.com. Go to the algebra 2, and then like the radicals stuff. This would be a good extra resource that I would recommend, because I think it'll even give you the answer key with the practice sheets. That might be to your benefit. So here's how this works. So I no longer have a monomial in the denominator. I got a binomial. So this is where we multiply by what's called a conjugate. So it's, again, we've used these terms before, but we're bringing them back in here. So here's how this works. Whatever's in that denominator spot, you multiply both top and bottom by square root of 5 minus square root of 3. So basically, you rewrite whatever you have in the denominator, you just change the sign. That's it in a nutshell. So as you can probably imagine, you have two binomials being multiplied. This thing's going to get pretty complex. So you're going to have 5 minus square root of 5 times square root of 5 minus square root of 3. So that's the top part. Square root of 5 plus square root of 3. Square root of 5 minus square root of 3. What's the weather saying, huh? Good. Okay. Yeah, by the way, we're having to watch the weather right now, so yeah. And turns out my wife did survive the toilet paper wars. I thought she got wiped out, but it turns out she's alive and well, sitting in my chair. So, would you like to say hello to the children?
Hello, children.
Hang on. Here you go.
Hello, children.
Hello, children. As you can see, where my children have been playing in my room. It's great, ain't it? Anyway, sorry, I digress. So, full method. So I'll start with the top part first. Pay really, really close attention to these signs. So you're going to have 5 square times square root of 5 minus 5 square root of 3 minus square root of 15. So easy to mess up right here. Kind of get your wires crossed. So slow down and pay attention to what you're doing. Okay, so square root of 9. So let's see, we got 5 radical 5 minus 5 radical 3. That doesn't break down, so we leave it as it is. And the square root of 9 is just 3. Now, you're going to be really, really tempted to try to make something out of all this, and you can't, so don't try. Because the 5, the 3, the 15, I can definitely see why somebody would. You can't. Don't try it. So I'm going to get myself some. So I'm actually going to bring this in the middle of the page here. 5 radical 5 minus 5 radical 3 minus radical 15 plus 3. Okay, so that's the top part taken care of. Now, let's deal with the bottom part. So square root of 5 plus square root of 3, square root of 5 minus square root of 3. Square root of 25 minus square root of 15 plus square root of 15 minus square root of 9. So that's 5. Oh, look at those. Those go away. Minus 3, which is 2. And believe it or not, as crazy. Hang on a second. Let me make sure I didn't miswrite anything here. Oh my goodness. That's a 5 right here. I made a slight mistake here, guys. That was actually a 5. I do have to make an amendment to this top part right here. The process was still right, though. I mean, as far as the process, I mean, I had it right. It's just I wrote the wrong thing down. That's what happens when you're working 9:23 at night after a long, eventful day. So 5 radical 5 minus 5 radical 3 minus square root of 25 plus square root of 15. So that top part should be, I'm just going to rewrite that. 5 radical 5 minus 5 radical 3 minus 5 plus square root of 15 all over 2. That is actually your answer, believe it or not. Nothing you could do there. You know, if all of your terms had a greatest common factor that could be pulled out, and it would have reduced with this, then you might have a little bit more you could do, kind of like that problem right there. But in this case, you're actually finished. So, my advice would be to rewind and play this over a lot again. I know I'm looking at your packet. Let's see. Yeah, you got, especially on the homework page, yeah, there's several extra practice problems. My advice would be to, try to work as many of those as you can. If you have access to MathWave or PhotoMath, by all means use that as a resource to kind of check yourself. But if you don't trust it, or if you just really want somebody to just sit down and just reiterate, I'll be happy to. Just shoot me an email and let me know. So let y'all go. Stay safe in the storms. Survive the coronavirus. And happy hoarding. Good night.